Good morning and welcome to this episode of Applied Networks, Resultant and Components of Forces. So this is a concurrent force in that all the lines of forces intersect at a central point. That's what is called an concurrent force. So we are asked to look for the resultant of all these forces, and we all know that the resultant is calculated as square root of summation fx square plus summation fy square. You can put the efy at the back or efx at the front. It's still the same thing. So, and for you to get summation of force, this x is for the horizontal. Horizontal is x, and this y is for the vertical. So you notice that these forces, there are some that are straight. This one is on the x-axis, 400 newton. This one is on the y-axis, 50 newton. But we have some that are not on x and y-axis. So we have to resolve them into components. And how do we do that? So let's take one. Summation of forces on the x-axis is equals to. So we are resolving each of these slant forces into horizontal and vertical components. So this is how we go about it. We resolve it to horizontal and vertical. This also we resolve it into horizontal and vertical. Here to horizontal and vertical. You can see. So here, let's just put this arrow to know where it's going to. So you can see this 200 newton. It has an angle of 30 acting to the horizontal. It is lying with the horizontal, and we all know that from the concept of forces of inclined plane, when you have fy rather, and you have fx, when you are calculating your f is equals to your fx will be equals to what? F cos theta, while your fy will be equals to f sin theta. So that's what we are going to be doing. So it's very simple, and that is when it is applied to the horizontal. Do you get? So let's just go straight to the point. So for this now, it's going to be 200. The horizontal will be cos, so 200 cos 30. Here will be 200 sin 30. And notice it is in a positive direction. This y-axis is going, this x-axis is going right, so they are positive. Here you can see that it's also acting to the horizontal. So you have 100 cos 45 for this, and for this you have 100 sin 45. Now I said for horizontal, when the angle is applied to the horizontal, the x will be what? Cos, then the vertical, the y-axis will be sin. So let's come in. So here we have this one facing down before we go there. So this one will be minus because it is opposite y-axis. It is minus y. So here, what do we have here? This one is not that this angle is applied to the vertical. So this will interchange. For the horizontal part, it will be, instead of cos, it will be sine. Then for the vertical, instead of sine, it will be cos. Why? Because it's acting to the vertical plane. It's acting to y-axis, the angle. So here it will be minus 300 sine 30. And here it will be, it's facing up, so we don't have to change it and put minus there. So 300 cos 30. So like we have gotten all our components. These are no more valid again. This 100, 200 and 300. Then we are making use of this, and this, and this. So do you understand? So now let's pick out our x-axis, the one on the either left, facing left or right. So we can start from anywhere. Let's start from 400. We have minus 400 because this is facing back. Minus 400 plus, we have this plus 200 cos 30. Then after that we have plus 100 cos 45. Do you have any other 1 2 3 1 2 3. Okay, we also have this two minus 300 sine 30. So if you calculate that, one by one, we have minus 306.1 minus 306.1 Newton. So that's for that one. So for the y-axis, you have to calculate all the components that are tending to y-axis. So we have this, we have this, we have this, and we have this. Those are the four. Let's start from here. We have 50 Newton. 50 Newton plus that Newton is not that value there. Here we have minus 100 sine 45. Then we have plus 200 sine 30. Then here we have plus 300 cos 30. So let's calculate. After you calculate that one, your possible answer will be, that should be 239. 239.1 Newton. So what do we do next? We now apply this. We apply this formula. So we already said R as the resultant is equals to summation of fx squared plus summation of fy squared. So you bring it in there. So what's our EFX is minus 306.1 square plus plus 231.1 square. So let's calculate that. Press your calculator. Minus 306.1 square plus 239.1 close bracket square. So your answer should be 388.4, which is approximately 388 Newton. So this is the resultant of this force. So that is the resultant. So in case you were not asked to calculate for the angle, that is the direction, because there are some questions that may ask you to calculate for the direction. Direction is known as tan inverse of summation fy over summation fx. So this is the formula for the direction. So if you could just permit me, let's clean this place so we can do that also quickly. So the direction, since we have gotten our EFY was 239.1 Newton, then our EFX was minus 306.1 Newton. So we are now applying the tan inverse of EFY is 239.1 over minus 306.1. So we calculate that. Let's press our calculator. Tan inverse of 239.1 divided by minus 306.1, and we close our brackets. Our answer is minus 30 7.99 here. So that's just it for this component of forces and resultants. I wish you good luck. Thank you.